Welcome. Whenever there is a no entry sign, there will always be some individuals who want to know why. What is behind the door or on the other side of the wall? Hello, my name is Paul and this is Barebones Tech. In the last two videos we explored the two most basic arithmetic operations, addition and subtraction. One of the tools we used to do this was the number line. We saw that we can view any value as a position on the number line. The number 2, for example, is here. I showed you that when adding, we move up the number line, as drawn here towards the right. When subtracting, we move down the line, as drawn here towards the left. We also saw that the line has an arrow on the end to indicate that it stretches on forever. The arrow means and so on. No matter how big a number gets, we can always extend the line further to accommodate it. If I draw the line so that it shows numbers up to 10, like this, but then try to add 7 and 5, I run out of line. But that is no problem, as I can just extend it. But what about the other end? It just stops at 0. It's a wall, a no entry sign. As mathematicians, we are those people who want to know what's on the other side. If I try to take 4 away from 2, I'm going to hit that wall. That's not very satisfactory. Well, logically there's no reason why I can't continue the line in the other direction, as far as I like. Since it could theoretically go on forever here as well, we can put another arrow on the other end. Now what? Well, we can now step past 0 and continue. 2 take away 4 will leave us here. But how should we describe that? Well, this position is the number 2, which we can also view as 2 units away from 0. We could, if we chose to, write it as 0 plus 2. Of course, that's a lot of additional work, and we don't like additional work. So just like all the infinite leading zeros in front of a number that I described in the video on number bases, we know that they are there, we just don't write them. How does this help? Well, let's take the argument a bit further. This position here is where we ended up when we took 4 from 2. It is also 2 units away from 0, but we can't call it 2 as that would lead to confusion with this 2. We could, however, also arrive here by saying that it's the solution to the subtraction 0 take away 2. Now again, we don't want to do any more writing than we have to, so let's forget the 0 and simply write it like this. We call this minus 2, or more correctly, negative 2. Great, so all the numbers on this side of 0 are 0 plus something. They have a hidden 0 and, conventionally, a hidden plus sign. But we collectively refer to them as positive numbers. All the numbers on this side of 0 can be written as 0 minus something. Again, we don't write the 0, but we need to write the minus sign to distinguish them from the positive numbers. And collectively, we refer to them as negative numbers. Negative numbers turn out to be immensely useful to us. If we consider the ground floor of a building to be 0, then we could use negative numbers to count the levels of basement. If we work with the Celsius temperature scale, freezing is 0, so colder than freezing is a negative number. In some cases, they're not welcome. If I have $100 in my bank account and I spend $150, then my balance becomes negative 50, which is probably not what I want. Let's see where this takes us though. Going back to the example from a couple of videos ago. On my number line, we can use the counting on method to add 3 and 2. We start at 3, face towards the right, and go forwards 2 spaces, 5. A similar calculation in the last video, we had 5 take 3, so again we start at 5, but this time face the left and go forward 3 spaces to land on 2. So addition is facing right and subtraction is facing left. Now, remember the associative property from the addition video? That said that 1 plus 2 plus 3 is the same as 1 plus 2 plus 3, and so on. And the commutative property, that's the one that says that 1 plus 2 is the same as 2 plus 1. Let's have a play and see where this takes us. 5 can be written as 0 plus 5. So 5 take away 3 can be written as 0 plus 5 take 3. Using the commutative property, we could swap the 5 and the 0 to give us 5 plus 0 take 3. The associative property tells us this is the same as 5 plus 0 take 3. But wait a minute, isn't 0 take 3 just negative 3? So we must have 5 plus negative 3. This means that subtraction is the same thing as addition of a negative number, or to put it another way, addition and subtraction are fundamentally the same thing. We can always rewrite a subtraction as an addition with the number negated. Mind blown! Addition on our number line requires us to face right, and the only way we can do that is if we move backwards. In other words, if the second number is negative, we just move backwards instead of forwards. Addition still has us face right and subtraction left. This leads us to some conclusions that will prove useful later on as well. What about negative 2 add 3? Follow the process. Start at negative 2 on the number line. Adding, so face right, positive number, move forward 3. Answer 1, which is the same as 3 take 2. So, as long as we keep the subtraction or negative sign with the number that follows it, we see that subtraction actually can have the commutative property as well. What about negative 6 add negative 3? Start at negative 6, adding, so face right. Number is negative, so move backwards 3. Negative 9. For my last trick, let's try 4 take negative 3. Start at 4, subtracting, so face left. Number is negative, so move backwards 3. Answer 7, which is the same as 4 plus 3. In other words, the principle of subtraction being addition of a negative number still works and leads to the conclusion that negative 3 is just positive 3. Wow! In the next video, I plan to move on to the next arithmetic operation, multiplication. If you don't want to miss that, by now you should know what is expected. Please ring the bell and subscribe. While you're at it, likes are appreciated and I'd love to read your comments. Finally, share the video with other like-minded folks who you think would enjoy it. Once again, my name is Paul and this has been Barebones Tech. Until next time, thank you for watching.